Hey everybody, this is our final lecture in unit number 2. We are using an example to identify and interpret the least squares regression line, the correlation coefficient, r squared, the coefficient of determination, and the standard deviation of residuals from computer output, or otherwise known as regression output. And that's exactly what we have here. In this box, we say this is called regression output, and we call it as such because it gives us all of the information we would possibly need to create our least squares regression line and then interpret all of the key features of a regression line and model. So the first thing that we want to think about is, well, what example is that we are looking at? Well, we're looking at the same example that we've been working with, and that's the truck example, in which we are trying to predict the price of a truck simply from knowing how many miles have been driven on that truck. Okay, and we came up with this regression equation that the predicted price is equal to $38,257 minus 0.1629 times the miles driven. And that's really important for us to at least start to remember what this regression equation is, so that way we can tie together how the regression output is going to relate to the regression equation. And hopefully you start to recognize, at least from the very beginning, a couple of key numbers here. We have this 38257. Which we know what that number is related to. And then we have this negative 0.1629. Make sure that you include in your notes the negative sign, because there is a typo in the notes, but the negative 0.1629, we should hopefully remember that that's going to be this number right here. So that's important for us to recognize that the regression equation is going to be shown in the regression output, and they're always going to be in these first two positions. How can we understand that, or how can we read this? Well, we have two things that are going to be used to make a prediction. One of them is a constant, or a y-intercept, and then the other is the explanatory variable. So the predictor that is the constant, we have to look at what's the coefficient of that constant. And the coefficient of that constant is 38257. Well, that's our y-intercept. That's our constant that, assuming we have no miles driven, the price of a truck we predicted to be $38,257, which means this first space is going to be your y-intercept every single time. The intersection between the coefficient and constant will always be your y-intercept. Now, the second one we have, the second predictor we used was the miles driven. Well, the intersection between the coefficient and miles driven, that's the coefficient of our explanatory variable, is negative 0.1629. So that tells me every time we will see our explanatory variable provided for us in writing, right here in context, and we will also know that the coefficient of that explanatory variable is going to be the slope. Okay? Now there's a bunch of other pieces of information which we actually don't need. The standard error coefficient, we don't need that. The t-values and the p-values we do not need until much later on. So all of this stuff here that you see, this you can kind of forget about, at least until the very last unit of instruction. Okay, the other pieces of information we want are going to be down below here. And that's where we get S, which you may remember from the last section was 5,740.13. That was our standard deviation of the residuals. So what's important about this number? Standard deviation of the residuals. We should remember that that is going to tell us the typical variation of the predicted price to the actual price. So here what we would suggest is that on average, the price that I predict for a truck will be off from the actual truck with similar mileage by about $5,740.13. Then we have this thing r-SQ. Well, that's r squared. And we hopefully remember that r squared is the coefficient of determination. And that is talking about the percent of the variation that is explained by the explanatory variable and this linear model. So from there we can find our coefficient of determination, standard deviation of residuals, and the actual regression output equation. This one, r-SQ adjusted, it's just another form of the coefficient of determination. We usually don't use it. It's not really wrong if you do use that one. We usually use the one that's just r-SQ. So remember that that is how you read through the regression output. Now there's one really important thing that we are missing, and that is our correlation coefficient, r. There is no r value. There is no correlation coefficient. And we think that's one of the most important things that we've talked about. We spent a good 2 lectures talking about the correlation between two variables and this correlation coefficient. It helps describe the nature of the relationship, the strength and direction. Well, if we notice that there is no r, but there is r squared, then all we have to do is take the square root of r squared. Make sure that you pay attention to the sign of the slope, because that's going to tell us the sign of r. That's important. So here's what we mean. If we take the square root of r squared, we are left with just r. You might think, okay, let's go ahead and do that. R squared is 66.4%. Take the square root of that, and we get about 8.15. But that's a problem. We should recognize that, nope, that can't be, because this is not correct. The correlation coefficient must be a number between -1 and +1. We don't have that here. So what do? We actually have to take the square root of the decimal, 0.664. And that's going to give us about 0.81. Well, this still is not correct, technically, because what do we need? We need to remember that there was a negative relationship between these two variables, as shown by our slope. That's why we say we have to pay attention to the sign of the slope, because the sign of the slope is going to tell us what r is. So we know that r is going to be a negative 0.81, which shows me there is a strong negative correlation between the miles driven and the price of these trucks. So from this, you're going to be able to not just derive the equation of the least squares regression line, but everything that you would possibly need in order to describe the relationship between these two variables. You'll also be able to evaluate its effectiveness. Okay? Now, the only thing that you really can't do is look at the residual plot to see if it's going to be appropriate. So that's still something you need. You still need to see the actual picture. Still need the scatter plot and the residual plot to see if you have an appropriate regression model. If you see that pattern in the residual plot, you know you have to try something else. Maybe it's something that's going to be quadratic, or it's going to be cubic or periodic or something like that. But if you can see that there's no pattern in the residual plot, the form looks to be linear, then the regression output is going to give you everything you need. So let's wrap everything up that we've talked about with the least squares regression line, the LSRL equation. In summary, here's what you're expected to be able to do with an LSRL and residual plot. You're going to need to first determine if a model is appropriate by looking at the residual plot. Super important you recognize that. Appropriateness comes from the form of your scatter plot and then lack of pattern in a residual plot. Then we should be able to write the least squares regression line, and you want to do it in context. Okay, this is very common for both your free response questions and multiple choice questions on the AP test. You want to interpret the y-intercept, slope, standard deviation of the residuals. All of these things should be able to be interpreted, and you want to make sure you're doing them in context always. Okay, then finally you should be able to make predictions using that least squares regression line. Okay, and also calculate a residual value. All of those things are things you're expected to be able to do with those least squares regression lines. So if you were lacking in any of that expertise, then go back to previous lectures to watch. Otherwise, thanks for watching, have a wonderful day, and I'll see you next time.